Let me just quick review this. So it got a little more complicated as we did it, but we just need to remember sort of the step-by-steps. Number one, the router evaluates the destination IP address of the arriving packet against all rows. So remember, it runs through every row, right? It's going to go through all 10 rows here. It notes matching rows. Okay, so this is like a memory process, right? Does a quick evaluation and then it notes the matching rows. Step 2, the router selects the best match. So which row matches the best using those rules we just did. Longest match wins. Ties go to the metric. Default row always loses. And then number 3, oh, and just a note, by the way, if you get here and the metric is the same and the match length is the same, it just picks the top row. So it doesn't go into some crazy loop. Oh, and then the last one, okay. So we select the best match row, and then finally, the router examines the interface and the next hop router fields to determine what to do with the packet. Okay, so if we look at these interface rows, and what did we decide? We were picking between 6 and 8, and we picked 6 as the best match. And our destination was 128, 171, 17. I don't even know where that is. It's okay. So now that it's decided to go out row 6, this is the best match, it's going to go out interface 3. If there is a value here, it puts the packet into a frame and addresses it to whatever this IP address's MAC address is. Sorry, this is a little more complicated, but that's tough. Because what's going to happen, here's my other diagram. Everything is on different pages. Here it is. So row 6 took me to here, right? Interface 3. So this internal router needs to send, maybe this was, I don't know, it was going out here. It needs to put the packet into a frame and it's addressed to this router. Because it needs to go to this router in order to be delivered further. You see that? There's 2 hops here. It has to go to this router next. That's why it's its next hop router. Now let's look again at the one where it matched. Where were we going here? Something.16, 21.16. We had one here that was addressed to the server here, 172.30.21.16. So the router got the packet, and notice here the next hop router field is blank. That means that the router is directly connected to that subnet, and it can address the frame directly to its destination host. Are we good here? So it has the destination IP address. It addresses the frame to its destination host. Are we good here with that idea? So here we're connected directly here, and we're going to deliver it directly to the host. For this one, we're not directly connected to that subnet, and so it needs to be delivered to that router, this router. We're okay with that. Now here's your question you're going to ask, hopefully is, when it got the packet, it had 172.30.21.16. How is it going to find out that the server's MAC address is D1 whatever? The switch does not have it. So if we have the IP address, we don't know the MAC address. Okay, so remember, we need to send these things, this needs to go in a frame. We know what IP address it needs to go in, or it needs to go to, but we don't necessarily know the MAC address it needs to go to. So what we do is we send an address resolution protocol message. Protocol, okay, ARP. So I'm going to use ARP, and what I'm going to do here is, here I am as the router, and I have my little port. I'm going to send a broadcast to the switch. And I think I told you guys, right? That's the server was here. There's another server here. This is .16, and it was D1. This one was .86, and it was E1. Right? And then there was a router here. It was .1 with an F1. Okay? We send out a broadcast message. Okay? And of course, there's a funky format to this, but it's not much more than what is 172.30.21, what do we do, .16? So we broadcast it. In order to do that, I think I told you this, we put all ones in a MAC address. So we can send out a broadcast frame. The router just puts all ones in the frame destination address. Are we good here? So the destination MAC address on this frame has all ones in it. Oops, I didn't circle that all the way, sorry. Okay. That means the switch is going to broadcast it to everyone else. Whoever that is, they will send back who that is. It will say 172.30.21.16 is D1 blah blah blah, whatever they are. Okay? And once the router gets that, then it sends out the frame. Yeah, well, it's not easy, is it? Networking, what a pain. So it sends out a frame after that with the right MAC address on it. So now it's addressed to D1, and then it will go. The switch will send it to the right place, and everyone's happy. And what do we need to know? ARP cache is 2 minutes long. Okay, so they'll remember, if someone sends them a reply, they'll remember that MAC address for 2 minutes, and that's all. Okay, after 2 minutes, they'll have to reconfirm it. So there's a timestamp on these. I say that because when we talked about broadcasts, and I told you about server broadcasts, and then I told you there was another broadcast that ended up being most of the broadcasts, and that's this one. So if you listen to a network, this is most of the traffic you'll hear, especially if you're on a switch network, because you only hear broadcasts, and then you'll hear all that stuff. It's fun.